Okay, so we're going to Gaussian house solving systems of equations. All right, let's take a look at the warm-up. Use substitution to solve a system of equation. Okay, so in problem number 1, we see that x equals -2. So we're going to substitute that value in for x and solve for y. So we have 2 times -2 plus 3y equals 8. Okay, so now we're going to solve for y. So 2 times -2 is -4 plus 3y equals 8. All right, we're going to add 4 to both sides. This becomes 0. You get 3y equals 12. Divide both sides by 3. 3 divided by 3 is 1, so y equals 4. Now, the solution to a system is a point, so that solution is -2, 4. All right, go ahead and finish up number 1. Let's take a look at number 2. All right, number 2, you see that y equals 4, so we're going to substitute 4 in for y and solve for x. So we have -6x plus 1/2 times 4 equals 4. Okay, now we're going to solve for x. Well, 1/2 times 2 is, 1/2 times 4 is 2, so that's -6x plus 2 equals 4. Subtract 2 from both sides. This becomes 0. You get -6x equals 2. Divide both sides by -6. This divides becomes 1. 2 divided by -6 reduces to be 1 divided by -3. So your solution is -1/3, 4. All right, go and finish up number 2. All right, let's take a look at number 3. So here we see that x equals y plus 1. So we're going to substitute y plus 1 in for x and solve for y. So we have 5 times y plus 1 minus, let's go and make that 1y equals 17. So now we distribute. 5 times y plus 1 is 5y plus 5 minus 1y equals 17. We can combine that 5y minus 1y, so that becomes 4y plus 5 equals 17. Subtract 5 from both sides. This becomes 0. You get 4y equals 12. So when you divide 4 by both sides, y equals 3. So your solution we don't have just yet because we have the y, but we need to find x. But we know x equals y plus 1. We can substitute 3 in for y and find x. So x equals 3 plus 1. So x equals 4. So the solution to this one is 4, 3. All right, go ahead and finish that up. And let's take a look at the next page. All right. Which fare is fair? You would like to take a taxi to the airport. There are 2 local taxi companies. Friendly's Cab Company charges $2.60 plus 20 cents per 1/6 of a mile driven. Anderson Taxi Inc. charges $5 plus 10 cents per 1/6 of a mile. All right. So first off, we're going to write the system equation. So let's start with Friendly's. Well, Friendly's is, and let me take a step back. We need to find a variable. So let's have x and y. X is the number of 1/6 miles, and y is the cost. Okay, so we know y then, our cost, is equal to, for friendlies, $2.60 plus 20 cents per mile. Okay, so now let's talk about Anderson. Okay, so we know y equals, in this case, it's $5 plus 10 cents per mile. All right, so now it says step 2 graph. Let's start by graphing friendlies, and we're going to graph friendlies in blue. Okay. Now, what we need to do is we need to plug 0 in for x, 1 for x, 2 for x to find y. We're going to do that for each of the points. And let's go ahead and use Desmos to do that. Okay, so we have $2.60 plus 0.20 times 0. Okay, so that's 2.6. All right. How about that? All right. Here we go. All right. So here are our points. And you'll notice that we did several points. Okay. And I did that so I can get a whole number of points. So we want to use this point and this point. You could use any points, but whole number of points are going to be easier to graph. So we're going to graph 2. And you can see here that if that's 4, this is going to be 2, 4, 6, 8, 10. So these are counting by 2, and these are counting by 1, 2, 3. Okay, so 2, 3 is right here. And then 7 between 6 and 8. So 7, 4 is right here. Okay, and you only need 2 points for a line. Okay. Now let's do Anderson. And let's go ahead and graph Anderson in red. Okay. And I've put several points because we want to get as many points as we can until we get, if we can, get whole number points. So we're going to plug in 0 for x, 1 for x, and so on. Okay. So 0 for x, 1 for x, 2 for x to get the y value. And let's go ahead and use Desmos to do that. Okay, I'm going to go ahead and delete the previous work, and then we're going to do 5 plus 0.10 times 0. And we can actually do this way. So you can actually go up and just keep changing the number. That's it. Could save some time in typing. So then 3. All right. So you see here we have our points, and we can use any of these points, but I'm going to use the ones that are probably easier: 0, 5, and 10, 6. So 0, 5, it's right here, and then 10, 6. Right. Now, you can see here that that point of intersection, but it's a little hard to see. We can see that it's 20, comma, but it's a little hard to see exactly what that y value is. So let's go ahead and use Desmos to find that exact point. Okay, so we're going to go to graphing, and so let Desmos load apparently. There we go. Apparently the internet froze for a moment. All right, so now we have 2.60 plus 0.20x. Let's delete this. Okay. There we go. A little technical difficulty there, but now we're back on track. So 5 plus 0.10x. And you can't see the intersection point, so when I zoom out, you can see that as soon as I do that, we have our point of intersection. So you can see I was a little off on the 20. It's actually 24, 7.4. So that's why using Desmos is going to be your most efficient way to check where your actual point of intersection is when it's not easy to see exact. Okay. All right. So we have a point 24, 7.4. Okay. So it says estimate the solution to the system of equations, justify your reasoning. The solution to the system of equations is x equals 24. This is the x-coordinate of the point where the two graphs intersect. The y-coordinate of the point is 7.4. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, solve the system equations algebraically. Now you can see here that they're both equal to y, so we can set them both equal to each other. So we have 2.60 plus 0.20x equals 5.0 plus 0.10x. Now, first step is when you have x's on both sides, you want to subtract the smaller x from the larger x. So we're going to subtract 0.10x from both sides. This becomes 0. Okay, so then you have 2.60 plus 0.10x equals 5.00. Now we can subtract 2.60 from both sides. This becomes 0. You get 0.10x equals 2.40. And then we just need to divide 0.10 from both sides. So 2.4 divided by 0.10 is 24. So x equals 24. Now, to find the y value, we can plug this number into either of these equations to solve for y. So let's just use the first equation. So y equals 2.60 plus 0.20 times 24. So let's go ahead and do that. So 2.60 plus 0.20 times 24 is 7.4. So y equals 7.4. Okay. All right, let's take a look at number 5. What does the solution mean in terms of the problem situation? The point of intersection is 24, comma 7.4. This means that if the distance to the airport is 24.16 miles, then the cost will be the same using either taxi company. Let's take a look at the next question. Suppose that Anderson Taxi decides to increase its fare to 20 cents per 16 mile driven. Write a new system equation to reflect the increased fare. When will the cost of using the two taxis be equal for the same number of miles? Well, Friendly's is the same, but now Anderson's is going to be 5.00 plus 0.20x, and that's Anderson's. Okay, now let's go ahead and take a look at the graphs to kind of understand the solution. Okay, so let's delete the previous problem. So we have 2.60 plus 0.20x. That's Friendly's. That didn't change. But now Anderson's is 5.00 plus 0.20x. Now you'll see here that the graphs are the same, but the y-intercepts are different. So these will never intersect. So the slopes of the equations are the same. The same. But the y-intercepts of the graphs will be different. So the graphs will not intersect. Fix that there. Okay. All right, let's take a look at number 7. Describe the different ways in which the two graphs can intersect and provide a sketch of each graph. The graphs can intersect at one point, which is one solution. The graphs will never intersect, which is no solution. The graphs will intersect infinite number of points, is infinite solutions. How does this relate to the number of solutions to the system of two linear equations? Intersect once, one solution. Do not intersect, no solution. Intersect infinitely, infinite solution. All right, let's take a look at the next page. All right. 1.1. Solving systems with a linear and quadratic equation. A system of equations can also involve nonlinear equations such as quadratic equations. The method of solving a system of nonlinear equations are similar to the methods for solving a system of linear equations. Number 1. Consider the system of linear equations and a quadratic equation. Use substitution to write a new equation that can be used to solve the system. Okay? So what we need to do is we need to solve one of these equations for a variable to substitute. It looks like we can solve this for y, and that would probably be the easiest way. So to do that, we're going to subtract 2x from both sides. This becomes 0. You get negative 1y equals negative 2x plus 5. We're going to divide everything by negative 1. This divides and becomes 1. You get y equals 2x minus 5. Now we can substitute that in for y and solve for x. So we have x squared minus parentheses 2x minus 5 equals 8. So we're distributing by negative 1 here. So then that's x squared minus 2x plus 5 equals 8. Now we need to move everything to one side. So we're going to subtract 8 from both sides. Okay. So we have x squared minus 2x minus 3 equals, that becomes 0. Now we need to factor this, okay? So x squared means 2 parentheses. equals 0. We know that x and x makes x squared because we know from reverse box method here, first term, last term. Now, the only way to get x squared is x and x. So that's the x and x. Now, we need to figure out what numbers multiply to give you negative 3 and combine to be negative 2. Okay? So, let's see if we can find that combination. So, since the middle number is negative, the bigger number is negative. So, 1 times negative 3 is negative 3. 1 minus 3 is negative 2. So, you have negative 3, negative 2. So, our factors are x plus 1, x minus 3. And we can check to make sure that works. Negative 3 times x is negative 3x. X times 1 is 1x. These combine to be negative 2x. So this works. Okay, so now we set them equal to 0. So x plus 1 equal to 0. X minus 3 equal to 0. So subtract 1 from both sides. X equals negative 1. Add 3 to both sides. X equals 3. Okay, now we need to find the corresponding y value. So we're going to plug these numbers back into either equation. It appears that this equation doesn't have the square, so that's probably easier to solve for. So let's do that. So when x is negative 1, we have 2 times negative 1 minus 1y equals 5. So 2 times negative 1 is negative 2 minus 1y equals 5. We add 2 to both sides. Run out of space here, so bring it back up. So that becomes 0. You get negative 1y equals 7. Divide both sides by negative 1. Y equals negative 7. So the point is negative 1 comma negative 7. Okay. Now let's go ahead and do that for 3. So when x is 3, we have 2 times 3 minus 1y equals 5. Well, 2 times 3 is 6, so that's 6 minus 1y equals 5. Subtract 6 from both sides. This becomes 0. You have negative 1y equals negative 1. Divide both sides by negative 1. Y equals 1. So your solution is 3, comma 1. Okay. All right, let's take a look at part D. We're going to graph and label. Okay, so I'm going to go ahead and do this in blue and this in red. And to graph these, Desmos is probably going to be the most efficient way. So let's go ahead and do that. Okay. So and let's go ahead and graph them both. All right. So now let's go ahead and graph this line first. We have those points are really good. So we can graph negative 1, negative 7, 3, 1. So negative 1, negative 7, and then 3, 1. Okay. Now, those points are also part of the parabola, so we just probably need one more point. Parabola 0, negative 8 works. So let's use that. 0, negative 8. And we know that the parabola goes through this point, back up through this point. Okay? All right. What do you notice about the solutions that you determined algebraically and graphically? The solutions are the same when you determine algebraically and graphically. All right. Let's take a look at the next page. Number 2. Think about the graph of a linear equation and a quadratic equation. Describe the different ways in which the two graphs can intersect and provide a sketch of each graph. The graphs can intersect at 2 points, at 1 point, or not at all. How does the relation to the number of solutions to a system of one linear equation and one quadratic equation? When the graphs intersect at 2 points, there is 2 solutions. When the graphs intersect at 1 point, there is 1 solution. When they do not intersect, there is no solutions. Can a system of linear equations and a quadratic equation ever have infinitely many solutions? Explain your reasoning. No, a system of linear and quadratic equations can never have infinite solutions because linear and quadratic equations can never be the same equation. All right, number 4. Solve each system of two equations in two variables algebraically, then verify the solution graphically. Now, you'll see here is that since they're both equal to y, we can set them equal to each other. Okay, so now we're going to solve. We're going to subtract 3x, and we're going to subtract 2 from both sides. So you get negative 1x squared. 2x minus 3x is minus 1x. 8 minus 2 is plus 6 equals 0. Now, we're going to divide everything by negative 1. This becomes x squared plus 1x minus 6 equal to 0. Now, we know 2 parentheses equals 0. X and x is x squared. Now, we need to figure out what numbers multiply to give you negative 6 and want to be positive 1. Since the middle number is positive, the bigger number is positive. So, negative 1 times 6 is negative 6. Negative 1 plus 6 is 5. That doesn't work. Okay, let's try negative 2 times 3 is negative 6. Negative 2 plus 3 is 1. We have our negative 6 and 1, so our factors are x minus 2, x plus 3. So we said x minus 2 equal to 0, x plus 3 equal to 0. Add 2 to both sides. X equals 2. Subtract 3 from both sides. X equals negative 3. Okay, so now we need to find the corresponding y value. So we're going to plug these values into either equation. I'm just going to use this one because it's easier. So when x is 2, we have y equals 3 times 2 plus 2. Well, that is y equals 6 plus 2 is 8. And then that's y equals 3 times negative 3 plus 2. So y equals negative 9 plus 2 is negative 7. So our solutions are 2, 8, and negative 3, negative 7. Okay? So now let's go ahead and check that graph, or verify graphically. So we're going to go to Desmos. Let's graph y equals negative x squared minus, plus 2x plus 8. And let's go and graph them both. Y equals 3x plus 2. And so we can graph this line probably first. That's going to be the easiest. So we have negative 3, negative 7, and 2, 8. So negative 3, negative 7, and 2, 8. Okay. Now, those 2 points are part of the parabola as well, so we just need 1 point from the parabola, which that one is good. And actually, we can graph 2, 0, 8, and 1, 9. So 0, 8, and 1, 9. So then we know the parabola goes up to this point, up, and then back down. Okay. All right, let's take a look at the next page. All right. I'm going to have you do this. Okay. All right. And then let's take a look at C together. Now, here, let's go and solve it algebraically. So we're going to subtract 4x from both sides, and we're going to add 1 to both sides. Okay. So you have 2x squared. This becomes 0. 3 plus 1 is plus 4 equals 0. Okay. So it equals 0. Now we solve. So we subtract 4 from both sides. So you get 2x squared equals negative 4. Divide both sides by 2. This divides becomes 1. You get x squared equals negative 2. Take the square root of both sides, plus or minus. The square root cancels the square. So then you get x equals the square root of a negative number. And let's just see what happens when we do that here in the calculator. So square root of negative 2 is undefined, okay? And the reason why it's undefined is because this is an imaginary number. The square root of negative 2 is I times the square root of 2. Because I is equal to the square root of negative 1. Okay, so this is an imaginary number. Almost forgot plus or minus. Okay, so that doesn't really make much sense when we're trying to find the solution. So let's go ahead and graph it to try to understand better, okay? So let's go ahead and graph. So we have 2x squared plus 4x plus 3. Oop. I'll put the squared here. Always look out for how you're typing. I'm about to. Oop. Didn't like that, so I have to delete there. There we go. All right, and then we have y equals 4x minus 1. All right, so let's go ahead and graph and see if we have points. That looks like a good point. That one doesn't maybe look so much. Let's see if we can find another point. You can kind of scan the. You can find one. 1, 3. Okay, so 0, negative 1. And 1, 3. Okay. And then see if we have some points here. 1. So there you go. Negative 1, 1. And 0, 3. And we know the parabola is coming like this. Like that. You can see that they do not intersect, so we say that there is no solution. Okay, go ahead and finish it up, and let's take a look at the next question. All right, Simon and his sister are playing a guessing game. Simon tells his sister that he thinks of two positive numbers. The first number minus the second number is 15. The square of the first number minus 20 times the second number is equal to 300. So the first says first number, so x, let's call that the first number. And then y is the second number. Okay, so first number minus second number is equal to, the word is means equal, 15. Okay, now the first number minus 20 times the second number. Oh, I'm sorry, the square of the first number. So x squared minus 20y equals, again, the word is means equal, 300. All right, so to solve this, we have x minus y equals 15. And x squared minus 20y equals 300. Now we need to solve one of these equations, okay, for a letter. Now, x has squared, so let's not solve that. Let's solve for y, because y is going to be a little easier. Okay, so we're going to subtract x from both sides, get negative y equals negative x plus 15. Divide this technically 1, so divide everything by negative 1. So you get y equals 1x minus 15. We're going to substitute that in for y. So we have x squared minus 20 times 1x minus 15 equals 300. Okay? So we have x squared. Negative 20 times x is minus 20x. I'm not quite sure what negative 20 times 15 is off the top of my head. So negative 20 times negative 15 is 300. So positive 300 equals 300. Now we can subtract 300 from both sides. That becomes 0, that becomes 0. You get x squared minus 20x equals 0. We can factor an x out from both, so that leaves x times x minus 20 equals 0. So x equals 20, and let's set x minus 20 equal to 0. Add 20 to both sides. X equals 20. Now we need to plug these back in and solve for y. And we can actually, I suggest we use this right here. So when x equals 20, y equals 1 times 0 plus 15 equals 15. When x equals 20, y equals 1 times 20 plus 15 . Oh, wait, almost made a mistake. And you want to be careful, is that says minus 15. I put a plus. So be careful. Little mistakes like that can cause you problems giving the wrong solution. So that changes things. So that's actually negative 15. And then this becomes 20 minus 15 is 5. Okay. The first number is 0. And the second number is, oh, I'm sorry, the first number is 20. And the second number is 5. The numbers 0 and negative 15 also satisfy the system of equations, but Simon said he was thinking of two positive numbers. Neither of these numbers are positive. Okay? All right, let's take a look at the next page. All right, 1.2, modeling with systems of equations. A photographer specializes in taking senior portraits. She records the amount of revenue she earns for each senior portrait package that she sells. Okay? Now it says use quadratic regression to write an equation to model the photographer's revenue. Be sure to define your variables. All right, so what we're going to do in Desmos, we're going to go to desmos.com. We're going to go to graphing calculator. And I'm going to go right here to this like hamburger, I guess is what you call it. And we're going to scroll down. We're looking for statistics. We want this linear statistics, linear regression. We click there, press open graph. Now we want to remove the table because we're going to put our own values in. And then we need to change this to quadratic. So we're going to write this as ax1 squared plus b. You have to put x1 for technology plus c. So now we have the quadratic regression. Okay, so now we plug in the values from the table. So 5, 10, okay, and then okay, and then if you scroll down, you see here that we're going to use the form y equals ax squared plus bx plus c, where a equals, okay, so we plug those values in, and then we have our equation. So y equals negative 1x squared plus 120x. And then c is 0, so we just ignore that. Okay. Now, it says each month the photographer must keep track of her cost and revenue. Her cost consists of a fixed amount of $1,400, which includes rent, utilities, and worker salaries, as well as $30 per package to print the portraits. Write an equation to model the photographer's cost. So x is the number of packages to print, and y is the total cost. So y equals $30 per package plus 1,400. Okay. Let's take a look at the next page. All right. Write a system of one linear and one quadratic equation to represent this problem. So we have that from the previous page. Now we're going to graph. Okay. So let's start by graphing negative x squared plus 120x. And I'm going to zoom out so now we can see it. It's a pretty big graph. Okay. And then we have 30x plus 1,400. Okay. And you're going to zoom in. You want to go back and zoom in to find the points of intersection. Okay. So, you can see here is one of the points of intersection. So we're going to write that down. And then we're going to scroll up. See here, when you click on the graphs, the intersections pop up. So then, okay. So when we graph this, 22,000 is right here, and 70, 3,500. So 3,500 is probably, these are counting by 200, right? So this would be 3,400, which is really close to 3,500. So we're just slightly above that. Okay. And then your initial point is 1,400. So that's this point right here, because we're counting by 200. So 2, 4, 6, 8, 1,000, 1,400. Okay. And that comes from that number. This point comes from that number right there. Okay. And then the parabola, we know 1.00. Okay. So we can start here. And it's a little stretched, but it goes here, gonna go up, and then back down, like so. Okay. All right. So solve the system of equations. The system has two solutions, 20, 2,000, and 70, 3,500. Okay. The photographer will break even if she sells 20 portrait packages because the cost and the revenue will both be the same. The photographer needs to sell between 21 and 69 portrait packages in order to make a profit. And that's because profit is above the line. So here's your profit. Okay, all your profit lies above the line. All right, go ahead and finish up that page. Let's take a look at here. Due to the rising cost of running businesses, the photographer anticipates fixed costs in the next year to be $2,400 per month, whereas the cost of the portrait packages will increase to $35 per portrait package. Write a new system equation to reflect the changes in cost. Okay. Due to rising costs of running business, the photographer anticipates fixed costs in the next year to be $2,400 per month, whereas the cost, so your new equation is 35x plus 2,400. Okay, so we can keep this graph, but now it's 3,500 and 2,400. Okay, so I'm going to zoom out, and we're looking for good points, okay, for the line. So 0, 2,400 is a good point, so we'll use that. And this will be in red, and this will be in blue. So 0, 2,400, and we need to find another point on that line. So one thing you can do is I'm going to de-highlight this line so I can just look at this line, and then we'll come back to that. Again, zooming out, see if I can find a $100,5,900. That's above our graph. So let's see if we can go down, see if we can find something. $70, $48.50, still above the graph. So we're looking for probably a whole number in 10. So let's try 40. 40, 3,800. Okay, that's a good point. Okay. So 40, 3,800 would be right here. Okay. And then here, I'm going to select that and then deselect this and then zoom in. 60, 3,600 is a good point. Okay. So 60, 3,600. And then we just need to probably find, let's press home. 0, 0 is a good point. And let's see if we can find, where cross is right there. 120, 0. It's not on the graph, but we can kind of mark that off. If these are counting by 5, 5, 10, 15, 20. So this would be 95. This would be 100, 105, 110, 115, 120. Could be about there. Okay. So if you just kind of, so we can use that point right here. Kind of, so we know the graph goes up. Come back down to there. Okay. Now, you'll see the graphs do not intersect there is no solution to this system of equations. Explain the solution in terms of problem situation. With the increased cost of business, the photographer will never break even. Okay, go ahead and finish that up and have a wonderful Wildcat day.